Jakai, you want to see us do some notations, right? Okay, we can do that. That's cool. Okie doke. Let's see. Notation time. In terms of notations, there's 3 different types of notations that you can see as my computer goes nuts. There is polar notation. And remember, polar notation is comprised of 2 parts. It has a size or a magnitude, and it has a direction. Oftentimes we can write this as the vector itself, the resultant r, and then some angle theta. And the big thing about this polar notation, whenever you're looking at that, is if I have an axis here, an xy axis, and my vector extends out into space, the length of this vector, that is r, that's the actual length of the vector, its physical interpretation of it, and the angle that we care about for this polar angle here is always from the x-axis over to the vector itself. That is angle theta, okay? And because of this, we know that through this first quadrant here, we have to have values of 0 to 90 degrees because this is the 0 degree mark and this is 90 degrees. Through here into quadrant 2, we're going to have anything between 90 degrees and 180 degrees. In quadrant 3, we're going to be between 180 and 270. And then through quadrant 4, we are 270. And then complete the third circle at 360. Okay? We want to be a little careful when we're doing this because, like I said, whenever we're creating polar angles, if our vector exists over here somewhere, and let's say that we're given this angle here is something like 20 degrees. Well, let's just say that our the length of this is something like 17. Okay? Then our polar angle here would be the size of this, 17, comma, and then the angle. And we want to be careful because, once again, that angle is from the positive x-axis all the way around. And I can easily get that because I know between the x and y axis is 90 degrees. And then 90 degrees plus 20 is like 110 degrees. So that second value would be 110 degrees, and that's the polar angle. Another example I could do for the polar angle is, let's pretend for a second I have something down here, and I know this angle is 40, and I know that the length itself is, let's just do 15. Then I know my polar angle here is 15, comma, and this is always the tricky part, starting from the positive x-axis, you need to wrap around. This is a little tricky and a little different from last time, because last time when we looked at this, we had 90 plus 20, because we just kept continuing. Here, I know as I go around to this, that's 180 degrees. But I have this little bit extra right here, and the question becomes, how do I get that little bit extra? Well, I don't know what that little bit extra is this time. This time, I knew that this down here was 40. Well, I also know that between the x and the y, that's 90. So that must mean if this is 40 here, this little extra right here has to be 50 degrees, because 50 plus 40 is 90 there. So what I can do is I can say 180 plus the extra 50 gives me what I have. And 180 plus 50, add the 0, 8 and 5 gives me 13, carry the 1, boom, 230 degrees. Okay? So it's not always a straightforward method on how we get it, but just by doing a little thinking, we can kind of see how to get that. Okay? So that's how we do polar notation there. The other big notation for us is rectangular. And rectangular is very similar to what we've always seen in math class, just x comma y. And basically what we're trying to do is we're trying to break up these two vectors into their x and y components. Okay, so if I just take a look at this top vector up here, vector 1, I have this blue line which is actually the vector, and what I can do to break it up into its x and y components, whoops, there it goes, is since I have this angle up here as being 20 degrees here in reddish orange, I can use that angle and I can extend upon the x and y axis to figure out the values. Since I have that angle, I can go up along the y-axis to begin with, as high as this vector allows. That's my y component. And then from this point, I could go over some amount. This is my x component. Now that I have a hypotenuse, and from this angle, an opposite side, because I'm going across the 20 degrees, and this is an adjacent side, well, now I can use SOHCAHTOA in order to find x and y. To find x for SOHCAHTOA, that's an opposite side. I would say that the sine of the angle, and the angle I have in this case is 20 degrees, 20 degrees equals the opposite, x over the hypotenuse, 17, multiply the 17 on each side, so that goes away, and I find the value for x. In this case, boom, bust out the calculator. I say 17 sine of 20, I get 5.81. I check to make sure I'm in degrees because radians can mess things up, and I have here that x is 5.81. If I do a similar thing for y, I would do the cosine of 20 equals y over the hypotenuse 17. Solving for y, I find that y is 15.97. Now what I want to make sure of here is, well, I have these two numbers and these two numbers will work. This y value is going up. It's going up here. It's given by the arrow. So it's a positive value. So that's 17.97. That's a positive number. It works. The x direction, I'm going to the left. The left is what we traditionally consider the negative direction. So I'd want to make sure I have a negative here, just like that. And then boom. That's how I do rectangular. I can do a similar thing with the triangle down here using either angle that I have. Notice and remember, I have both the 50 degree and the 40. So if you'd like, you could set up your triangle down here by going over with the 50 degrees here and then down, or using the 40 degrees, you could go down and then over. Remember, this is your x, this is your x, this is your y, this is your y, but when you set up your triangles, this would be an opposite side coming across of the 40, and this is the adjacent going across the 50. This is your opposite side, and this is your adjacent. So if you're using this upper triangle, these are the values you have. If you're using the lower triangle, these are the values you have. So notice the y value could be adjacent or opposite depending on your triangle. Note in either case, your hypotenuse is always the hypotenuse. Okay, so play your SOHCAHTOA game there, have fun. In this case, both quantities will be negative because they're both going to the left and they are going down. So negative x, negative y. Just real quick, what you would get there if you actually wanted to do those. I'll do this for the 40 right here. With my x being the opposite, I would have 15 sine of 40. My x is negative 9.64. For my y, I'd do 15 cosine of 40. I'd get negative 11.49. And that's rectangular. Okay. If you wanted to do unit vector, You can quickly do that by simply taking the x number and the y number and just rewriting them. Negative 5.81 I hat plus 15.97 j hat. It's just x quantity, y quantity with a plus in between. Not a comma, not a semicolon. I can rewrite the second one, negative 9.64 I hat plus, or you could call it minus, because this is a negative 11.49 j hat. So if you want to say plus negative, that's fine. If you want to just say negative or subtraction, that's fine. The key here is that you're using the I and j hat. They are just the x and the y quantities, followed by I hat and j hat. Okay? And that's how you do unit vector notation. Those are all the notations. Hope that cleared that up. Ninja Kyle. And Ninja Kyle, I don't know if you have